Welcome to another class with Ming. Today we talk about expansion from a geometrical point of view. Before we learn about ABX, this expansion, question 1 and 2, the expansion in black can be thought of this way, geometrically. That is, the first term here is the width of an area, a rectangular area, and the second term here is the length. So this is the width B plus C. So this is the length B plus C. So you can think of it as there is a vegetable plot, and B is where you plant broccoli, and C is where you plant carrot. And the total area, obviously in this case, is A times B plus C. And you can see that this is equivalent to the area in the broccoli is A times B, and the area in the carrot plot is A times C. So the total area must be AB plus C. Thus, our equality here. And we can also think about the second one like this. Instead of it being arranged this way, the width now is A and B together, and the length is just C. So here will be the total area, therefore will be A plus B times C, which is A times C times plus B times C. So I add those things together. Therefore, this is what we have. Now, we also learned about these 4 things here, the expansion for this thing. In fact, all the 3, 4, and 5 are special cases of x plus A times x plus B. Question number 3 is, you can think of it as A plus B. So in my case, I've considered A here as my x. So you can think of the A here as being the x. A here is being the x, and see this one is become x squared, and here is bx, and here is bx, and here is b squared. So the total area of this thing, x plus b everything squared, becomes x squared plus 2 of bx plus b squared. Thus, this is exactly the same as 3 if I replace A by x. Now, can you do geometrical proof from number 6? That is, you draw a diagram similar to this one to prove that 6 is written this way. Alright, you may want to pause the video, draw a diagram, and once you're ready, resume the diagram. The answer for that will be something like this. For example, okay, you get something like this. So now you have the width now, instead of B now you have A, and the length now remain as B. So you can see now x times x gives you x squared. Here is AX, and here is BX, and here is A times B. So therefore you have x plus A times x plus B is equal to x squared plus A plus B times x plus AB. Therefore, this is my geometrical proof. Now, I have not done 4 and 5. I will leave 4 and 5 as an exercise for you. You might want to discuss your geometrical shape with your teacher. Question number 4 and question number 5. Alright, here is another exercise that you may want to try. Here we have, you need to expand 2 terms, AX plus B times CX plus D. Well, you can do it 2 ways. Either you can do it with algebraically, maybe you want to do it first algebraically, and 2, you can try to do it geometrically, drawing a rectangular box, appropriate boxes, and give it a try. pause the video, give it a try, and then once you're ready, resume the video. Okay, so we're going to first do it algebraically. So first is ax times cx, so that becomes ac x squared. Then ax times d, that becomes ax d or adx, plus b times cx, bcx, plus b times d, bd. So simplifying this, I will have ac x squared plus adx plus bcx plus bd, or in another simplifying once more is acx squared plus ad bracket plus bc with a common factor x plus bd. So you can see that, well, one way to remember is that to get the answer, AC comes from the coefficient of x's. AC comes from the product of the coefficient of the x's, and BD comes from the product of the constant term. And in here you have AD plus BC, that is the coefficient of x times the constant term plus the coefficient of x times the constant term of the second term. So coefficient of x times the constant term. Right. This, well, you can try to memorize this formula if you wish. Personally, I find this formula very difficult to memorize. I would just do the expansion. Another way to think of this is to look at it from a geometrical point of view. That is, you have a box. Here, the width is AX, A times X, plus B, and the length C of X plus D, like this. So if you have this, then the area of the orange box is simply AC x squared, and the yellow box is ADX, and the green box is basically this times that, so it's BCX, and the blue box is BD. So it's easy to see now that AX plus B times CX plus D is just sum of the different boxes. There is ACX squared plus AD plus BC times X plus BD, which is exactly the same. So we have that. Here, in fact, this is the most simplified form, most general form of all the things that we had before. So here we have 3, 4, 5, 6. In fact, all of these are part of question number 7.